Okay guys, today we are starting a new unit. We're starting chapter 4. And if you look up here on our focus board, our unit goal says I can evaluate real-world examples using multiplication and division of fractions. So last chapter it was the exact same thing but with decimals. So now we're going to go through a lot of the same similar processes but with fractions. So the multiplying of fractions, dividing of fractions, all of that kind of stuff. Okay? You defined 3 terms for your bulwark. The first one that you defined, I believe, was Venn diagram. Am I right? Mm-hmm. Okay. So when we're looking at a Venn diagram, you probably use this a lot in language arts, like when you're comparing and contrasting maybe characters or settings of a story, something like that. So when we're looking on like these sides, this is what each individual thing has that's different, right? And in the middle is what they have in common. That's where they overlap. I believe that word overlap is within your definition of the Venn diagram. The second word that you defined was common factors. Somebody tell me what you got for the definition of common factors. Got it. Factors that are what? Factors that are shared by 2 or more members. Okay? Then you have something that's called the greatest common factor, or for short, the GCF. And what is the GCF? Dante.
Greatest common factor, meaning the greatest of the common factors of 2 or more numbers. The GCF of 24 and 30 is 6.
Perfect. So, if we know what a common factor is, it's kind of, well, greatest common factor, it's the greatest common factor between 2 or more numbers. Good. Okay. As I was telling you, we're going to look at a few different methods on how to find the greatest common factor. We're going to look at prime factorization, so we're going to revisit that. We're going to look at division ladders, and we're going to look at Venn diagrams. And we're also going to look at listing them out, or as some of you might know, it is like a rainbow, but we're not going to make the rainbow when we connect one number to another. Okay? And you'll see what I'm talking about if you're not quite sure. Okay, so the first thing that I want to show you, so today's objective, I can find the greatest common factor, or the GCF, of 2 numbers. That's kind of the goal, but we're going to do some practice with up to 3 numbers, okay? So the first thing that we're going to do is prime factorization. So your title for today's notes is going to be GCF. And then you can just write prime factorize underneath, or you can write it method 1 using prime factorization. Okay, so remember with prime factorization, that's a factor tree, okay? I'm going to look at 16 and 24. You should be writing these down. 16 and 24. Cece, how can I split up 16? And? Huh? 2 and 8, not 2 8. Remember, this is multiplication. So 2 and 8. Nani, what do I need to do from here? 4 and 4?
I mean 4 and 2.
4 and 2. The 2 R prime, 4, what are we going to do to it? Split it into what? 2. So here, the prime factorization is 4 2s, right? Okay. Now I'm going to come over, I'm going to leave that alone for a minute, but I'm going to come over here and prime factorize 24. Max, how can I split 24 up?
6 and 4.
6 and 4. Great. Haley, what's my next step?
3 and 2.
3 and 2 for 6. Austin, what do I need to do to 4? 2 and 2. Are all of my numbers now prime?
No.
Yes. So Nancy, for here I have 3 times 2 times 2 times 2, right? So I'm comparing. I'm looking at what the prime factorization is for 16, and I'm looking at the prime factorization for 24. What do they have in common? Sophia. You hit it right on the head. I was ready to hear, well, they've got 2s. Specifically, they have 3 2s in common. Okay? That's what they share. Not 6. 8, because we're multiplying. Good. The answer is 8 because 2 times 2 is 4, 4 times 2 is 8. So the GCF, because 2 times 2 is 4, 4 times 2 is 8. And somebody said, well, what about the other side? Well, it doesn't matter that it's 3 2s on one side and 3 2s on the other. That's what they have in common, and you only do it once. Okay? Nami.
If it's like 3 is in common, does that mean the answer is going to be
47. So you would do 3 times 3 times 3.
So it's going to be like R is 0.
Like it might be, they might say that we have a 3 over here, and a 3 and a 2 and 3 and a 2, then you would multiply the 3 times the 2. And you would get 6. Okay? We're going to keep practicing. We're going to do like 2 examples for each method. Okay? All right. Still sticking with prime factorization.
So you don't have to multiply the 2 things you get together, you just have to multiply
One side, yes. Okay. No, because the other one doesn't have a 3. Okay? Okay, now let's use, 36 and 45. So use the factor tree for that. So take a minute and go ahead and try and factorize. Remember, in prime factorization, you got to get down to all prime numbers. Jacob, how can I break up 36? 6 and 6, sure. Why not? Next out, what am I going to do next?
Well, 6, well, 3 and 2 can go to 6.
Whoops. So I can do that on both here. 3 and 2, 3 and 2. Are all of these prime? Are 3 and 2 prime? Yeah, so I'm going to write that out just so I can see it better. Okay, 45. Amelia, what can I do to break up 45? 5 and 9, absolutely. Okay, is one of these prime?
Yes.
Which one?
5.
5. What about 9?
No, you don't put in 3 and 3.
3 and 3. Okay, so when I look at this, I've got 3 times 3 times 5. Cece, what do you notice?
But they both have 2 3s.
They both have 2 3s. So here's this 3 and this 3, this 3 and this 3. Haley, what's my answer? 9. Good. So the GCF here is 9. Yes, sir.
That's good. Because 44 minus 16 is 8, and 45 minus 30 is 9. Like that makes it what?
No, you're just noticing some relationships. That's good. Dante?
Do we, in our notes, do we have to write every method?
Yes. Okay, so for notes today, we're going to practice every method, but when you do your independent work, you choose your method. I'm not going to make you stick to one method. But you've got to do what works best for you. Okay? All right. Second method, division ladders. I showed you division ladders when we first started talking about prime factorization, and several of you were like, yeah, no thank you. Now with this, it might be one where you guys are actually like, oh, this one is neater, it's right to the point, you know. Again, you pick your method. All right, so we're going to write our numbers a little bit closer to each other. So I'm going to use 18 and 30. And so they're on the same line together. And then I put an upside down division house. Okay? For both of you, you write it just like that. Okay? It's like we're going to divide two numbers at once, but it's with a simple number, okay? So we're going to think about our division rules, divisibility rules, and for the most part, you would stick with like 2 or 3, possibly 5, but you're going after those prime numbers to put out on the left side. You don't want to use a composite number unless you know that that's as far as it's going to go, and I'll show you what I'm talking about here in just a second, okay? So, when we're looking at this, both of these numbers are what? Even. They're both even, so we can use what?
2.
We can use 2, absolutely. So, we could use 3, yes, but for right now, let's use 2. So now you look at it. 2 will go into 18 how many times?
9.
9. And you put that 9 underneath.
And then
And 2 will go into 30, 15 times, and the 15 goes into the 30.
And then you draw like another upside down.
And you're going to do another division. It's going to look like an upside down ladder, okay? Or I saw an example that it even says, like, if you drew the next line up, it looks like an upside down cake. Okay? Whatever works for you guys. Okay? Yes, sir?
You could use 3 now.
I could use 3 now. Okay, so Griffin, how many times will 3 go into 9? 3? Make sure that you're taking notes. Yes, sir? 3 goes into 15 5 times. Okay? And this is the part that gets confusing with this one. This is where I need you to just open your mind and listen. Joe?
Are the numbers supposed to get closer together?
You mean like in spatial? They don't have to, it just happens to be that that's how I'm doing it. Because I brought this in, but that does not matter. But to make it look like a ladder, it kind of, you drop this in. Okay? Nani?
So this is the 2 times 3?
Yes. You're going to ignore the 3 and the 5 over here. Okay? This is what they don't have in common. So when we were looking over here at the factor trees, these 2, 45 doesn't have 2, and 36 doesn't have 5, right? So when we're looking at the division ladders, 3 they both have, but 18 has an extra 3, okay? But 5 doesn't belong to 18. So this is what they don't have in common. This would be the outside parts of a Venn diagram. So then you take this, so the 2 and the 3, the two numbers on the left are what you multiply together to get the GCF. Okay? So just like when we were looking at, just like when we were looking at the prime factorization, we have these two numbers that we multiplied together, and we got 9. For the division ladder, we have these two numbers that we multiply together, and we get 6. Okay? Brendan.
So, why would we still have the
Okay, so there's some confusion as to, well, you have these numbers out here, why are we leaving them alone? So let's look at it if we were to use prime factorization, because you were with me with prime factorization. So if I broke this up like this, everybody's with me there, okay? Then I break this one up okay? You with me here? Alright? So, a 3 and a 3, they both have 1 3 in common, right? Does 30 have another 3? No. Does 18 and 30 both have a 2, right? Okay? Does 18 have a 5? No. So I'm only looking at 3 and 2. So look what's left, 3 and 5. Oh, I did it side by side right here. 3 and 5. That's what's left. Haley.
So it's basically just a less floppy way, isn't that?
Yes. If you want to look at it that way, it's a less floppy way than doing prime factorization or the factor trees. That's fine. But it's really, again, what you use. Okay, it's what you got to do. All right, I'm going to show you one more method that's kind of a combination of two. Okay? So we're going to look at the Venn diagram. And you might like them, if you're a visual person, you might really like the Venn diagram, but they're not necessary to solve it. Okay? So if I'm looking at, have we used 12 and 66 yet? No. Okay. If I'm looking at 12 and 66, and remember I told you we would kind of talk about the rainbow?
What?
One of the ways that I really, in order to find the common factors and the GCF and all of that, is to list them out like this. Starting with the factors of 1 and the number itself. So 1 would go here, because you're writing them from least to greatest, which means 12 would be the farthest outside number, right? Then you start working your way in. Anything times 2 gives you 12? Right, so the 2 goes here and the 6 goes here. Then the next thing is 3 and 3. And 3 times 4. So you're squeezing it in, alright? So again, 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Okay? Sophia? Okay, so the reason why, and that's good, is because the first example that I gave last hour, I just listed them and they weren't in order. When you list them in order and you put them on top of each other like this, you can visually see the numbers a little bit better. Okay? And it helps you squeeze in and make less errors to forget factor pairs. Abby?
So, what happens, like, mine, I can't space it out too much, so I don't have a space gap.
That's fine. I do that all the time. It's just a gap, it's not a problem. Okay? Brendan?
Well, you know how, like those 12, and you put those down? Well, what if you went over to 4, and you did the same thing?
What do you mean?
Like you did 1, 2, 3, and how much they go into 12. And then you go on to 4, and then you put the 3.
Well, if you've already listed 3 once, you don't list it again.
You know,
Okay. So now 66. 1 is the left number. 66 is the right number. This is the smallest number. This is the largest number, right? Okay. Then you just start working your way through. The next number is 2. 2 times anything. 33. So that goes over here. What about 3?
13.
22. 3 times 22. Okay. What about 4? 10 through 4? Okay. What about 5?
No.
Why? It doesn't end in what? 5 0. Okay. What about 6? 6 and 11. So then the numbers that we have left, we have 7, 8, 9, and 10. Anything times 7 going to give you 66? Anything times 7, or 8?
No.
Times 9?
No.
Times 10?
No.
So this is your list. Now, you can make a Venn diagram, wow, of these two numbers. So they both have 1 in common. So I got that taken care of. They both have 2 in common.
3.
Yep, 3.
Yeah.
No 4, so 4 goes, this is 12, and this is 66. 66. So 6, I'm sorry, 4 goes over here. 6 they have in common. Then I have 12. Is 12 listed over here? No, so it's all over here. Then I've got 11, and nothing, it doesn't go any further, so everything else is over here. 11, 22, 33, and 66, right? Okay, so we look at this center part. What is the biggest number that's listed? 6. And that's your GCF. Now, you could do this exact same thing, though, minus the Venn diagram. Okay? And I'm going to show you how to do that. So we're going to do 3 numbers. We're going to do 8, 27, and 36. What are my factors for 8? We don't have to even worry about putting them in order if we don't want to. We can just list them. Griffin.
1 and 2.
Well, give me the pair. So 1 and 8. Then what? What else? Nani? 2 and 4. Anything else? No. All right, what about 27? Max.
9 and 3.
9 and 3. Give me another one.
1 and 27.
1 and 27. Can you think of anything else?
Nope.
Nope. Okay, 36. Talk to me. 6 and 6. I don't need to list it more than 1.
9.
12 and 3.
9 and 4. 12 and 3. 9 and 4.
12 and
Got 12 and 3. Got 9 and 4. Got 6. I think 2 and
18.
18. All right. So I wanted to write them to where they weren't in order so you could see why I put them in order. Now you got to kind of look through and think, okay, where's this number? If they're in order, they're a little bit easier to follow. All right. So 1824. 1824. They got a 1 in common. They got a 1 in common. So right now I'm just circling common factors. There's not a 2 here. Okay.
It's the 1 and 36 letter.
Yeah, we just do 1 and 36.
There we go. How did we forget the easiest one? Okay. Now let's drop down here. Let's see. Well, here's the thing, guys. The only thing they have in common between these two is 1. That 2 doesn't go to 27. So the only thing that these three numbers have in common is 1. Because 1, 8, 2, and 4, 27 doesn't have 2. Doesn't have 8 and 4. 8 and 36 have a lot more in common. Okay? Griffin.
So would that be 3?
No, it would just be 1. So here's the benefit. I want to review this real quick. Prime factorization, you have to multiply the two numbers together. Okay? Division ladders, you have to multiply these two numbers together. Whether you're looking at putting it in a row like this or putting it into a Venn diagram, you just list the number down. There's no multiplying in this method. Okay? Use the method that works best for you. Try a couple of different methods today. Okay? Any questions? Nope. Okay. I want you to look at page 200. We're going to look at a couple of word problems together before I let you work independently. Do this quickly, page 200. Okay, if you'll look at number 23 with me, if you'll notice up above the number it has some instructions about the story problem itself. So follow along as I read it aloud. Yes, this will say in notes. Annika is placing photos in a scrapbook. She has 8 large photos, and I'm going to take notes while I'm reading. 8 large, 12 medium, and 16 small photos. So pay attention to the next part. Each page will have only one size of photo. So a page of smalls, a page of mediums, a page of larges. She also wants to place the same amount of photos on each page. So there's going to be 3 larges, 3 mediums, 3 smalls, or whatever the number is that we find out. So number 23 says, what is the greatest number of photos that could be on each page? What are we going to do? Find the what, Gavin? We're going to find the GCF. So when I look at these 3 numbers, let's see. Haley, which method would you like me to use? Division ladders. I'm going to use division ladders. You use what method works for you, and you see if we get the same thing, okay? So I'm going to list out 8, 12, and 16. I notice that they are all what? Even. So I'm going to go ahead and use 2. 2 goes into 8 4 times. 2 goes into 12 6 times. 2 goes into 16 8 times. These numbers are still composite, and they are all even, so I can use 2 again. 2 goes into 4, how many times? 2 goes into 6, 3 times, and 2 goes into 8, 4 times. Now, here's the tricky part. When you get down here, like, well, Miss Adams, 4 is composite. You're right, but whenever we are looking at the prime factorization, we might have an extra number off to the side, okay? It would be like another set of 2's. If we were to factor that out, it would be another set of 2's, but that would be unique to 16. They don't have that in common. So the only thing that they have in common are 2 2s. If we were to use the factor tree for all 3 of these, we would notice that the thing that they had in common was that each tree would have 2 2s. Now I have to do my next step, which is what, Haley?
Add the multiplying
2, right. And I get 4 for my GCF. So this answers, for number 23, this answers the greatest number of photos that could be on each page. Okay? Now look at 24. 24 says, how many pages will she use in all? How would we solve that? How would we use our GCF to solve number 24? What do you mean? Divide what?
Divide all the numbers by 4. Well, 8 divided by 4. 12.
So if I did that, then I would get 2 and 3 and 4.
And then plus.
And then add them. Well, why am I... Okay, so here's what Max is saying. Well, I've got 8 big pictures. If I divide 8 by 4, that means I'm going to have 2 pages of large pictures. If I divide 12 by 4, that means I'm going to have 3 pages of large pictures.
And then you're not 4, so you're doing the same thing.
Okay, what's my final step?
9.
Add them all.
Add them all together to find out how many pages in all. Good. Okay. So that you have enough time, I'm going to go ahead and show you your assignment. We are going to, I accidentally put the wrong number here. We're going to work on page 200, 10 through 22, evens. I want you to pick your method, but you have to show your work. You cannot just write the answer. Even if it's super, 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 super easy, you have to show your work.